I am Wasim Shinkada. This is our second project in machine learning, pattern and logistic regression. Logistic regression is a machine learning algorithm used for binary classification. In our project, we use it to predict whether students would be admitted to university based on their test scores. Dataset 1 and whether a microchip passes quality assurance. Dataset 2, it works by estimating probabilities and applying the threshold. There's threshold on classify data into one of two groups. Explanation dataset. That's our dataset. Dataset 1 has two features. Scores from two exams. The goal is to classify students and as admitted or not based on these scores. Dataset 2 involves two features from quality assurance tests. Here the data is more complex and cannot be separated by a straight line, requiring advanced techniques like feature mapping and regularization. Let me come back to our code. Before applying linguistic regression, we prepare the data. Future scaling for dataset 1. The two exam scores have different ranges. Future scaling ensures that both futures contribute equally to the models. Training by standardizing them to common scale. Future mapping for dataset 2. The raw futures are not enough to separate the data. We create additional polynomial futures to make the discussion boundary more complex and suitable for the problem. How the model works? The model learns to classify data by adjusting weight and basis. Adjusting weight and basis. These are parameters that determine how much influence each future has on the prediction the process involves. Calculating prediction based on the current weight and basis. Comparing prediction with actual result to compute the error. Adjusting weight and basis to minimize this error using the method called gradient descent. This function, gradient descent. Once the model is trained, we can visualize the discussion boundary for the dataset 1. It is the straight line because we assume a similar relation between the future. I will run our code. For the dataset 2, the boundary is more complex due to future mapping, showing how will the model separate accepted the rejected microchips. regularization. On dataset 2, we apply regularization to avoid overfitting. Overfitting happens when the model performs too well on the training data, but poorly on unseen data. Regularization adds a penalty for overlay complex models, ensure sorry, ensuring they generalize better to new data. The regularization stride is the controlled by parameter called lambda. Which we tune to find the best balance between fitting the data and avoiding overfitting. Gradient ascent, gradient descent. The model learn by repeatedly adjusting weight and basis to reduce error. Gradient descent is the optimization process that drives this learning. It ensures the model improves over time by taking small steps in the direction that reduce error that most. After training, we evaluate the model's accuracy. Accuracy is the percentage of correctly predicate outcomes for data set 1. Accuracy is limited to the assumption of linear boundary. For dataset 2, we achieved better accuracy, but using feature mapping and tuning the regularization parameter. This is the plot discussion boundary for dataset 1. We have this point on the plus is admit, and the other is unadmit. This is plus one is like I say admitted, and the circle one is not admitted. Future scaling isn't for ensuring all future contribute equal during training. Regularization prevents overfitting and ensure the model performs well on the new data. That is regularized logistic discussion boundary for dataset 2. Future mapping always the model that handle nonlinear relationship in the data. This one. Discussion boundaries demonstrate the separation achieved by the model. Conclusion. This project shows the power of logistic regression for the classification problems. We started with a simple data and built a more complex model by scaling future, mapping them, and applying the regularization. The visualization of discussion boundaries help us understand how the model works, and the occurrence metrics confirm it is effectiveness. By Combining this technique, we solved both a simple linear problem and challenging non-linear one. And compute and printing accuracies. The training accuracies for dataset is 90%, and training for accuracy dataset 2 with best lambda equal 0.01 is 75.42%. Thank you and have a nice day.